Hi folks, this is Jack, I'm Tim. Over the last couple of weeks, the medical community in Galway has come together to look at a number of issues that may arise due to the current COVID-19 pandemic. Clinicians, industry experts and researchers have all been working together on a number of projects. These projects are being headed up by Professor of Anesthesiology and Critical Care Medicine, John Laffey, and the Director of the Translational Medical Device Lab, Dr. Martin O'Halloran.
So several work streams were set up between NUI Galway here and the Galway University Hospital. We have been focused on a stream looking to address the shortage of invasive ICU ventilators.
And over the last couple of weeks, we've conducted hundreds of tests and we've iterated many times. Close and constant clinical feedback, strong industry support, and a highly motivated team have allowed us to think fast, to work fast, and to work smart. We believe we now have a safe system that allows one ventilator to be shared between two patients with a titratable tidal volume and pressure.
So the purpose of this video then is to explain the different components that go into the system and how to configure them as we have specified. We have also developed a website, GalwayVentShare.com. We'll be using this as an online platform to share more detailed instructions, what parts are required and where you can get them, and also the data sheets from the testing that we've done. We'll be updating this as we have further developments to the system, so if this is useful to you, then that's the GalwayVentShare.com is where to go to find more info.
So, onto the system.
Okay, so what I'm going to do here is run through the different components in the system and the assembly. The way that we're laid out is we have, coming from the ventilator on the right side, we have the inspiratory line. Coming back to the patient level components in the center, and then coming back through the expiratory line to the left hand side of the ventilator here. So I'll go through these components and assemble them one by one. The first thing to do is to split the inspiratory line into two branches. To do that, we're using a standard Y connector. In this configuration, the Y connectors actually need a female to female connector on both ends to fit the system. Following that, then we have our APL valve set up. So how we're using this APL valve is slightly different to its standard use. Typically it would be on top of a C circuit in a T configuration with the flow going this way, and then any excess pressure just being vented to the atmosphere through this large port here. How we're using this slightly differently is to run all the flow through the bottom using this elbow, and then we're using a step down connector on the exhaust to route into the inspiratory limb. In effect, what that does is it brings all the flow through the valve, which can be now used as a variable flow restrictor. So that's in its fully open position there, and now we have two of them. So we connect these via the female to female connectors, one for each patient, and then that is your full inspiratory limb assembly, and that plugs directly into the ventilator. I know some centers would use a HEPA filter right here, and so that can be just plugged in after the HEPA filter. If I come down then, I'll take our standard breathing circuit. We'll run one of the arms as the inspiratory limb for our first patient. That is going to run through to a flow meter, which comes right before the patient's mouth. We are in this case using a HME filter that's rated for bacterial and viral in order to prevent any contamination between patients. So that will attach right there, and that goes in as per your standard practice onto the ET tube. Now this flow sensor is where we are going to connect the individual patient displays. That will be done via a cable here with a clip. So that goes on like so, and then this cable is routed back along the breathing circuit and will be attached to a small display on either side per patient with the patient's individual tidal volumes and pressures and PEEPs. So I'll leave that there, and we will start to attach our second patient circuit. So again, we have our second breathing circuit, and we will have our inspiratory limb attached just post the APL valve here. Again, we will run that through our flow meter and the HME. Now if we come on to the expiratory side, in order for the APL valve to function properly and effectively reduce the tidal volume and pressure for this patient, we need to ensure that the line can't backfill through the expiratory line. A second reason that we'll be doing this step is to prevent any crosstalk between the two patients, so that we can effectively adjust either patient independently without affecting the other. So all we need to do for that is run a one-way valve at the end of the expiratory limb, obviously flowing back towards the ventilator. That then will be attached into a standard Y connector. And I'll just assemble the second patient's one-way valve here as well. So now we have our two patients going to one Y connector, and then as a sort of a fail-safe for contamination, before we run that into the ventilator, we'll have an extra HEPA filter here at the end. And now the HEPA filter, because it's on the expiratory line now, requires a female-to-female connector similar to the Y at the other side, and that will then connect directly onto the ventilator. And that's your full tidally controllable ventilator sharing circuit.
All of the parts of this system are medically approved components. We have repurposed the APL valve, and it's now being used as a flow restrictor. But it comes in a C-circuit kit, and we're working with the manufacturers at the moment to see if they can release it as just a component with the step-down connector. So that's, unlike all of the components in the system, we are working with manufacturers. We're trying to understand their capacity and ability to supply, and we'll be making those, all that information available on the website. We'll be adding contact details, component numbers, etc., to facilitate people that perhaps don't have them in the hospital already. But we have aimed to have a system that you would have most of this equipment available to you in the hospital. We also have 3 projects that are currently working in parallel to work on the solution for the patient measurements. So, as outlined in this this display here, we're looking to get peak pressure, we're looking to get tidal volumes, and we're looking to get PEEP. So they're looking very promising, and that work is ongoing. And again, we'll update everybody on the website as and when we get further details with that. So we hope that this information is useful, and we hope to talk to people soon.